So next, we shall be talking about functional groups. What are functional groups? They are atoms or group of atoms which forms a unique part of a homologous series. That is to say, functional groups are certain species attached to any given homologous family which impacts chemical characteristics to that homologous family. That is to say, they are the most important aspect of that homologous family, the given homologous family, or what gives or defines the characteristics of that homologous family. A good example is, as we can see, in alkenes, the functional group in alkenes is the double bond. The functional group in alkynes is triple bond. But alkanes really literally have no functional group. So examples of functional groups and the homologous series to which it is attached are as displayed on the screen. Alkanes, we have seen their general molecular formula, that of alkenes, alkynes, and alkanols. So for a functional group, alkanes literally have no functional group. They're just straight hydrocarbons. Alkanes have functional group which is double bond. Alkynes is triple bond. Alkanols have the functional group which is OH, that is the hydroxyl group. And the hydroxyl group, like we said from the beginning of this lesson, that they help to impact polarity to alkanols. And that is why alkanols are soluble in water. So that is the functional group for alkanols. We have alkanals. The functional group of alkanals is, as we can see displayed on the screen, C double bond H. Alkanols is C double bond O. Alkanoic acids, which we have talked about, is C double bond O OH. Amines is NH2. Amides is C double bond O NH2. That is a functional group of all these. We have alkyl halides, esters, which we've just seen, ether, and nitrides. So these are all functional groups. It is worthy to note that R and R prime may be the same or different alkyl group, as in with respect to esters. When we're talking about esters, just like we did when we just did esters, the R and the R prime may be of the same or different alkyl groups. Okay. Away from that, we shall now be talking about IUPAC nomenclature. That is, we are now looking at how to name organic compounds. The system of naming an organic compound can be done by two major ways. We have the first, which is the trivial or common system of naming compounds, and then we have the IUPAC naming system. IUPAC naming, or the systematic naming system. Let us take a look at the first method of nomenclature. That is the trivial or common naming. In the trivial or common naming system, straight chain alkanes are normally called normal alkanes or N-alkanes. Good example is, as we can see displayed, for butane, we just simply call N-butane. And the other compound is N-heptane. If, however, the chain is branched, then such a compound is referred to as an iso or a new compound. What do we mean by an iso compound? When we have a structural compound given and the last but one carbon atom is carrying a CH3, that is a methyl group, such a compound is called an iso. As we can see on the board, the last but one carbon atom is having a CH3 attached to it, so it is properly called isobutane because there are 4 carbon atoms, and we have said 4 carbon atoms is but. It can be butane, it can be butene, it can be butane, it can be butanol, depending on the functional group. But as we can see in this case, there are only single carbon bonded atoms. So for that reason, it is not an alkene, it is not an alkyne, neither is it an alkanol. So it is an alkane because they are saturated. So it is called isobutane because there are 4 carbon atoms. Now when the hydrocarbon is carrying 2 methyl groups, that is to say, when the last but 1 carbon atom is carrying 2 methyl groups, one at the top, one below, it is called a neon. So for such compounds, we simply call neo compounds.